Howdy, folks. So in this video, this is part 2 of our looking at the evolution simulation. I'm going to look at the scripts that I use to manage spawning, and also some of the details around the critters. So you'll notice that in this class, I reworked this class. This is something I had before I had sort of mushed into some of my other scripts. And I broke it out to make a class. I called it spawning scripts so that I could use it in other places. And the main place I'm going to be using this is over in day and night cycle, which I'll talk about in the next video in a little bit more detail. So our ability to spawn things, I have 3 different things that I really wanted to focus on. I wanted to spawn food, and I wanted to spawn critters, and I wanted to be able to spawn a child based off of a parent. So the idea that we would make a baby and it would share some properties with the other ones. And so if I have all these separated up here, if I ever want to change the algorithm, I know exactly where to go and I don't have to search for it. So spawn food, I actually have a real fancy way that I did this one time, and then I thought of, you know what, that's annoying to do it that fancy way for most people. So I came up with the simplest way I could think of, which this does is notice how in the last one we talked about our world data, right? So our world data keeps track of things like how big the size of the world is and where the food should be. So I can then use that in these calculations. So for instance, I can make the food zone size here. I just check out the world size, I subtract the buffer, and I divide it by 2, and that gives me sort of the radius of the area that the food can be in. And then I sort of pretend it's a grid. So once I have that number, I basically start at negative that number and I go to positive that number. So if we imagine 0, 0's in the middle, I start at, let's say, negative 40, and then I go along and I do negative 40, negative 39, 38, so on and so forth, counting up to positive 40. And then I do that similarly vertically. So I kind of just check every box in the grid. Imagine a piece of graph paper. I just try to visit every cell. And then what I did is I rolled a die and I said, hey, if the food check number is less than my food spawn chance that I made, then I'm going to instantiate a piece of food there. That's it. So I basically go around. If you imagine I have a piece of graph paper, I visit each cell, I roll a random number, and if it's less than the or equal to the number there, then I put a piece of food there. So it's really easy for me to go into world data and change the food spawn chance. Right now it's at 0.03, so 3%. So there's a 3% chance that any one square will get food. So that gives me plenty of food, because if it's 80 across and it's an 80 by 80 space, that gives me quite a few spots where food can be. And so I could play with this. I had it at 1% for a while. You could even put it lower if you wanted food to be sparse. And then the nice thing about this is that it's kind of unpredictable where the food's going to be. So creatures might get lucky or unlucky, have it spawn close to them, which I thought added to a little bit of the fun. So this is a pretty easy way to generate the food. And now the nice part about this is that anytime I want to spawn a floor full of food, I can just call this function. And so then I can refresh the food at the end of the day, or whenever I want, which ends up being pretty handy. So there we go. And I can kind of show you how that works. So if I click on day and night cycles, you'll see that in my thing, I will make a spawning script spawner, new spawning scripts, and then I can just go in here and do spawner.spawn food or spawner.spawn critters, and it will create all those things for me. So I don't have to worry about it. And it calls those functions. Okay, so but we'll get into more about the day-night cycle a little bit later. So here's Spawn Critters. Spawn Critters uses a very similar idea. We're gonna explore our space. And this time what we do is we want to spawn the creatures on the edges. And so I do a little math to find where the edges are. So I find sort of how wide the short part is and how long the long part is. And then I just sort of roll a die to decide which combo I should pick. And then it will, put it in that strip. And so if you take a look at it, it's fairly reasonable. I roll a dice between 1 and 4. I generate 2 random numbers. This is in a smaller range. This is in a larger range. And then depending on which quadrant I'm in, I either use, I'm either going long, short, long, but I do negative so that it's the on the opposite side, or I do short, long, and then opposite side, long. So that's one way to think about it. And so that goes through and it compares it to the world data dot starting population. So see here how I used all this world data stuff so that I don't have to, like, let's say I put 100 here. And then everywhere, or world size, every place I use world size. Think of all the places if I suddenly want to change the size of my world. I'd have to change it here, I'd have to change it here, I'd have to change it here. I'd have to change it in all these spots. But now I can just change it in one spot and I get it for free everywhere else. So the last one is Spawn Child. This one will make more sense once we go over critter and critter stats. So in this case, what we're doing is we're doing a lot of the same stuff with finding the boundary. And actually, I did something different just so you kind of see a different way to do this. Here, I made extra variables to hold the X location and the Z location, and then I just set them based on the random range. It's exactly the same as how I did it here, except for I took it away from the instantiate. Turns out one of the reasons I did that is so that I could copy when I did the instantiate, I instantiate it and I make a copy of it into the child variable so I can then edit the properties of that new child. So in this case, when I instantiate something, I get past a critter, which is basically the parent. And so when I get past that parent, then in this case, I want my new stats not just to be the base speed. So if I instantiate a new copy of this, it would be exactly the same. So I want to go in and say, hey, guess what? I want to change that by multiplying it by this number here. So it's a little bit different. So in this case, it's the random range between 0.9 and 1.1. So it basically can change a maximum of 10% each generation. So this is one that I think I could do a lot of fun stuff in here to change how their traits evolve. Like I just did a simple multiplication, but maybe I only want it to mutate some of the time. So most of the time you'll be exactly the same as your parents. Maybe some of the time you'll be different. Things like that. So there's a lot of room to do some extra stuff. And I probably could simplify this down a little bit. I might have done a little bit of extra work in here, but for the most part, I do that. And then because it copies over the critter stats, I had to change a couple other things. I had to set its food to be eaten to be 0 because the parent actually will have eaten plenty of food to reproduce. And so I have to set it to 0 so it knows to go look for food when it gets made. And then I have to say, hey, you're not at home. And so that's just a little bit of the clunkiness of when I set it up. And so that could easily be adjusted somewhere else to make it a little thing. And then I have a little thing here, a little function that I made in critter control, which I'll show you in a second. It says update agent speed. And all that does is it copies the speed of the critter into the navmesh agent so that it the variable speed matches what we just changed. And so that makes it handy because then I can keep track of the speed and have it actually move that fast. So that is all of our spawning. So that'll make a lot more sense once we take a look at our critter. So I made another helper function for critter. And I want to show you this because I did a couple of things that were kind of nice for it. So one, I put all my variables related to critters in here. So it's easy for me to add critters, set their default values, just like with the world data. That ended up being pretty nice. But I also, because I did that, I was able to use this command called serializable. So I did using system and I made it serializable. And what that does is it's really cool. So if I come over here and I run my simulation, and let me pause for a second, and let me find one of these critters. Okay, so there's a critter over there. Notice that in my, let me turn off my, here, let me move this so you can see it a little better. You'll notice that there's a little thing that says my stats, right? Like that was that class that I made. It's like, that's it's holding all those variables. So by making it serializable, I can then make it so even though I don't want to like set them in the inspector, I can make it so they're visible. So I can easily click on any one of these agents. Okay. When I click on it and make sure I click on the critter, not just the clone, not the body, I can look and see what's my current energy, what's my current speed, what's my current vision, what's my, current size, how much food have I eaten? Am I wandering? Am I, at home? All these things. So I can check all the stuff that I might want to be able to quickly do it. And, maybe my final version, I might disable that, but it was super helpful for troubleshooting when I was running into problems with like them running out of energy or not eating food or things like that. So those are the stats that I have, and that's the serializable. So when we go into critter control, you'll notice that now I can use this serialized field. And if you put serialized field, if the thing is serializable, this one we made ourselves, so we had to tell it to be serializable. If it's serializable, then if you put this above it, when you define it, then you can see here, I created a critter stacks object, my stats, new critter stats, and then it'll show up in the inspector like that, which I found to be super handy. Okay, so in the critter control, this one's got a lot of stuff in it, so it's going to take us a minute to get through. So in this case, I have my stats, I have my nav mesh agent, I have a thing called found food collider, which is telling me to go find if I found some food. And then I have a couple of things that are where I live and what my current target is. You'll notice these are vector 3s, which is slightly different than how I did it in class. I made an adjustment to make it work a little bit better in this version. So when I start off, I update the agent speed, and that's just in case I change it in the critter stats to be something other than the default nav mesh agent stats. And then I grab the agent and I set the home location to be like where I just got created. And so that's one that maybe I would do a little bit different later on. Like maybe I would have them have little villages on the end, and so there would only be a few different home locations. But this basically says wherever you got made, go back to that place at the end of the day. So I have a couple of different things going on here. So one is Starvation Check. And Starvation Check is, did I use all of my energy? And so basically it just says, hey, if my energy gets below 0, I die. That's pretty easy. Then I have, this is kind of my little state machine here. And so you can see here, I left myself a note to clean this up. And I'm like, yeah, I could totally make this function a lot nicer than I did here. But that's what I did this time. So anyways, here I have a question. I basically say, am I at home? If I'm at home, I don't want to do any of this stuff. I basically am done for the day. And so this update kind of stops running once I go home. But if I'm not at home, then I'm going to use some energy. Okay. And I just used what they did in energy burn here. And so in this case, I just used the square of my speed plus whatever my vision is. And that's how much energy I burn per second. and then I multiply it by time dot delta time, because that's how much time has elapsed since the last time I ran update. And so that lets me take away a really small amount each turn and not have to worry about killing them too fast. So so now I'm like, this is how much energy a second I use. And then I might modify that to some degree if I wanted to. I could increase it or don't. And that's why I made this function, is to get a little bit fancy. You'll notice that I have, like, if my stats at home equals false, return this, otherwise return 0. That's actually left over from when before I had this check, right? Because this check won't ever let this happen, but I didn't change it because I just wanted to show you that this evolved over time, and sometimes you forget to clean up your code. So I use some energy, and then I basically check, hey, have I eaten enough? And then I go home. So if I eat enough food to reproduce, I'm just going to go home at that point. I should have plenty of energy to make it home, and I want to try to reproduce, so I'm going to walk home. Otherwise, well, what am I going to do? Well, if I haven't found any food, I'm going to go look for food. Okay. Then so let's take a look at that. Find nearest food. Well, we talked about this in class quite a bit. And in this case, find nearest food uses that overlap sphere to look for things. We sort the objects and we find the closest one that's food. And we're just setting it to red to help us know that we found some food. But then we checked our food collider to be the other thing. And then basically we said, hey, if we found some food, that sounds great. And what are we going to do? We're going to set our current target to be the position of the food collider. And we're going to tell ourselves that we're not wandering anymore. So that's really important. It's like, once I find food, I don't want to be in my wander mode. I want to be in my go to that food that I saw mode. That's going to be important for the next one, okay, which is if I'm currently supposed to not be wandering, but I don't have food, that means I got to the food, then I want to call the wander function. Or I made it to the position that I was going to. So that means I was wandering, but I got to where my wander target is. Then I want to call the wander function. You might wonder, like, why aren't I just calling wander like every time, or, more frequently than that? Well, the reason was I had a problem before, which was my wander function. They would just sort of like walk in little circles. And so I was like, I need them to like travel a little bit longer before they check again. Otherwise they don't make it anywhere. So this is my little check for that. Wander is pretty straightforward. Okay. It says it changes to wandering is true. It picks a random direction here to go to. And then it's going to pick right here a position, double check this little bit of code right here, double checks that the thing that you picked is actually on the nav mesh so you don't accidentally shoot off into space. And then it sets the current target. Okay, so right now, those are our main things. Okay, and then after if I'm not at home, then I'll just go to whichever of the targets I set. And that right there is my critter control. Okay. If I ever decide to go home, I just set my current target. I call the go home thing, which says basically, hey, my current target equals my home location. Great. And then it also checks to see, did I get home? And so in this case, I check to see if my position, the X and the Z, match up with the home's X and the Z. And the reason for that is that sometimes there can be a little bit of, because of how the nav mesh agent works, sometimes the Y will be a little bit higher than you expect it to be. And I don't care about the Y, so I just check those two. And then once I get there, then I'm set at home. And then I stop doing my updates and I'll just sit there until I get to the end of the day. So this one ended up being a little longer than I wanted, but hopefully that covers in pretty good detail the critter control. And then I'll talk about the other two scripts next time.